Hi, welcome to the Geographic Information System class, especially about datum, map projections, and projected coordinate systems. Let's begin. I will focus on three topics, namely spatial and non-spatial data sources, and the discussion of two map projection methods, geographic coordinate system and UTM projection. First, we will discuss the spatial and non-spatial data sources. There are several data sources that can be used. Two sources commonly used as spatial data are analog map and remote sensing system data. Analog map includes topographic maps, land maps, and other forms that are classified as print mode maps. This source has a spatial reference such as coordinates, scale, cardinal directions, and so on. Remote sensing method or remote sensing system data, namely the science of obtaining information about an object, area, or phenomenon through data analysis from a device without direct contact with the object, area, or phenomenon. This remote sensing method consists of several forms, namely, 1. Satellite images, 2. Aerial photography, 3. Field measurement result data, and 4. GPS or global positioning system data. The first method, satellite images, refers to images taken with a satellite device. The ability of the sensor to record the smallest object in each pixel is referred to as spatial resolution. There are three levels of resolution for satellite imagery, namely, low, Landsat satellite, medium, spot satellite, and high, IKONOS or QuickBird satellite. The second method, namely aerial photographic imagery, is a type of image that results from recording the Earth's surface using aerial photography vehicles, both airplanes and ground-based remote sensing. The third method, field measurement result data, is a field measurement with separate calculations whose final product is a source of attribute data, such as administrative boundaries, land ownership boundaries, parcel boundaries, or forest concession rights boundaries. Lastly, global positioning system technology being the last known method is also an important breakthrough in providing GIS data. Meanwhile, for non-spatial data, the data sources that can be used can be secondary data from related agencies such as population data from Central Statistics Agency, climate and weather data from Meteorology, Climatology and Geophysics Agency, road data from Department of Public Works, and so on. All data obtained can be used to create an Earth projection system that will be contained in the form of a ball or map. Pouring the data into a projected image requires a mathematical equation called the coordinate system to define the position of the GIS data above the Earth's surface. There are two types of coordinate systems commonly used, namely the Geographic Coordinate System, GCS, and the Universal Transverse Mercator, UTM. Geographic Coordinate System, GCS, is a feature referenced by longitude and latitude. Both are angles measured from the center of the Earth to a point on the Earth's surface in units of gradient. In practice, GCS follows the rules of the Cartesian coordinate system, x, y, with the point, 0, 0, at the intersection of the equator and Greenwich. Both longitude and latitude will cover the surface of the globe and form a grid network called graticule. This graticule will help us in making map projections. There are several categories of projection systems according to Peter H. Dana, Colorado University, namely astigmatism, cones, azimuthal, and other systems such as combining several methods. Unfortunately, practically we cannot completely avoid distortion when transferring data on a globe surface to a flat plane. The distortion in question can be in the form of image deviations being unequal in area, shape, distance, and even direction. So in practice we must ensure the objectives to be achieved from the map projection. The UTM projections method as an alternative to GCS is a projection system method that divides the Earth's image into 60 zones. The advantages of this system are that it allows each divided area to have a symmetrical projection of 6 degrees, a formula that can be used for worldwide zone transformations, as well as relatively small distortion, ranging from 40 cm to 70 cm per 1,000 meters. Some important terms related to this UTM system are easting, northing, northern hemisphere, and southern hemisphere. Easting refers to the distance in meters from the central meridian with a predetermined center meridian of 500,000 meters. The southern hemisphere is defined as 10 million meters at the equator and decreases in value as it moves south. In the context of Indonesia itself, the appearance in the GIS map image shows that from the west to the east, Indonesia is located in UTM zones 47 to 53. The longitudinal cross-section of this region is divided into 6 degrees north latitude and 12 degrees south latitude. This UTM application in Indonesia allows the division of territory in Indonesia into 9 zones.
Thank you, and see you in the next course.